Welcome everybody. This is the sprint demo for Evernym's 18th sprint this year working on the Hyperledger Indy project. We've been posting these to the Evernym channel on YouTube and we hope you enjoy them. If you have any questions about this demo, please join us on Rocket Chat at chat.hyperledger.org and we hang out in the Indy-SDK and Indy-Node channels there. So if you have questions, we do hope to see you there. Today we're going to cover a couple of things. First of all, we're going to talk about the Indy SDK. This sprint, we did a lot of cleanup, a lot of bugs. We also continued our work on preparing LibVCX to be used by the broader open source community, by the Hyperledger Indy community. LibVCX was created by Evernym for internal use for our products. It's a higher level abstraction for credential exchange, and it proved really useful. We wanted to give it to everybody else, but it needs some re-architecture to work the way that the Indy agent community wants it to work. So we've been working on that re-architecture. We also have been working on some bug fixes in the CLI are the main things we've done today on the SDK team. The first thing we want to show, Oi, Darko, you're on the call. I thought you were on a plane. Do you have audio?
Hi, yes. Well, I came here yesterday, I think, by US time.
Excellent. That's great. We were nervous you were traveling. So I'm sharing the Getting Started guide for LibIndy you created, a much requested document. What would you like to share with people about it?
Well, I created a document by copying the similar one from Indy SDK, so LibIndy, and I made all calls to use LibVCX, so the script scenario is the same, and you may see how these things may be done with the libVCX. Most of the calls are much simplified, like where in LibIndy you would have like 5 to 6 calls. Often here you will have 2 or even 1. So
fantastic. That's excellent. And as soon as we're off this call, I need to Slack this and Rocket Chat it to about 5 people who've asked me for it. So I'm really excited that you got this done. Thank you very much. So this is all, it lives in Hyperledger's Indy SDK GitHub repository. In the VCX subdirectory, there's a docs subdirectory in there with a getting started folder, and it's a markdown document there. So we do, it'll benefit people who are getting started with libVCX, and we, of course, accept pull requests and improvements. So thank you. Anything else you want to say about it, Darko?
No, that's pretty much it. I checked with Doug about the calls, and he said that it looks correct.
Excellent. Thank you for doing that. That's excellent. Artem, I'll stop sharing my screen so you can take us through the CLI work with wallets. We're seeing your screen. Excellent.
Hello, everyone. My demo is about one of the most important bug fixes we have done this sprint. This bug fix is about Indy CLI, to be more specific, how Indy CLI works with wallet. After global wallet refactoring, LibIndy doesn't resist any wallet configuration files in his folder. So to Indy CLI be able to work with wallets and provide list of all wallets, it stores wallet config file itself. Because Indy CLI wasn't able to work with wallets created by third-party applications like LibIndy, and we have added 2 commands to solve this problem. I would like to demonstrate a little demo how to work with these commands. So I have in the CLI started in my IntelliJ IDEA here. Let's check. Do I have any wallets? No. My wallets folder is empty now. And also I have have a little test in LibIndy that creates a wallet and stores the ID. Let's run it. The wallet has been created and the ID has been stored. Let's go back to the Indy CLI and try to check wallet list again. This list is still empty because Indy CLI doesn't see this created wallet. To be able to work with this wallet, we have to call wallet attach command. This command has multiple params. These params are similar to params that have wallet create command, except keys. So let's attach my wallet. It's successful. And now I can open this wallet. So wallet has been successfully opened, and let's try to check.
Artem, I missed. How did you get the name wallet_1?
I have wallet config here and this ID.
Oh, okay. Excellent.
Okay, and let's try to check list of the DIDs. So we have one DID in this wallet. Its DID is similar to we have created later. Let's close my wallet. And we have added a reverse command, wallet detach. So let's try to check the list of the wallets now. The list of wallets is empty. And I'd like to try to open the LibIndy wallet again. And the LibIndy CLI told me that wallet admin isn't attached to CLI. So that's it.
Excellent. That is a very common use case that we realized was hard to do. So thank you for solving it for us. That's going to benefit a lot of people. Now we're going to talk about the Indy Node team. Indy Node's been working on, I stopped sharing my screen. The Indy Node team has also done a lot of bug fixing this most recent sprint. A lot of the work we've done has contributed to his solve bugs that were raised a while back. A lot of these stories were raised as solutions to previous bugs. And specifically some bugs around the way promotions work between the test net and the live net. We've also worked on some design issues, figuring out how to handle multiple signatures for trustee actions. That's going to be really useful for protecting the network. So let me stop sharing so that Andre can share. Andre's going to take us through how to fix the bug with re-verifying signatures.
Okay. Can you hear me?
Yes, we can hear you.
During the sprint, I was working on do not re-verify signature for Propogates issue. The main goal of this ticket is to improve performance by avoiding redundant verification of request signatures in Propogates messages. As you can see on this schema, for all incoming Propogates, before fix, we will make an auth procedure, and the total count of calling this procedure is about n+1, and it's count of propagate message, and also one is request message. After fix implementation, as you can see, we calling authenticate processes just one time, and for other incoming propagate messages or requests for this request from client. We just use already verified identifiers from cache. For making this improvement was created an additional map which contains already verified requests, and we make verify signature process. Just look at this map, and if already verified signature for this propagate message, then just return validated identifiers. Also, we write a simple test. Just check that after receiving 5 requests, for example, we making only 5 authenticate processes. Also, last load test showed that our average throughput for NIM transactions, for example, is increased from 20 to 25 cents per second average. Oh, test done. That's all from my side.
Excellent, thank you. We've done a lot of load testing in the last few sprints, and we shared those results previously, and it's helped us identify certain bottlenecks like this one. So it's nice to see a significant increase in throughput from that fix. Thank you for doing that and explaining how it worked. One of the challenges we've had with our load testing is we need to make sure that it handles that when payments are made, specifically with the sovereign network, that it doesn't impact the, or that we minimize the impact that has on throughput. And so Dmitry has extended load testing scripts to be able to manage those circumstances where payments are made using the sovereign network's payment processes. Dmitry, can you share those results with us?
Okay, let me try. Okay, we continue working on our performance script. Now we make it as a separate package. Oh, sorry. Now it is available from pip, and we can install it. Here we go. Now we have our performance script inside our system. The main changes were connected with seed parameters to allow to pass several seeds for several addresses, and X parameters. This parameter contains all the settings that related to fees. Let's see what it can do. We pass several addresses to able to multisig our payment transactions. We use lips of token to make payments, and we set those fees to our pool. We minted NIM transactions, untrip transaction, and schema transactions. And this parameter shows that we're gonna test following type of transactions.
Dmitry, where does this performance testing script live in GitHub?
For the moment, it lives in Indy Node repository, but we hope to make it as a dedicated repo.
Excellent. We also have that testing automation repo, Indy test automation.
Yes, probably this is the best place for it.
Yeah, excellent. That's good to know. For anybody watching the video, the LibSoft token plugin is the payment system available through the Sovereign Foundation.
Okay, that's all from my side. We were able to set fees and run several transactions with fees.
Excellent. So next sprint, we're going to be able to look at what the performance is when using, when making those, paying those fees. So I'm excited to see those results. Very good. Thank you for that. So the next sprint, we were working on fundamental feature changes in both Indy SDK and Indy Node.
Sorry, Richard, it's a wrong
backlog, thanks. When we were working on fundamental feature changes in Indy SDK and Indy Node, we had to put a lot of fixes on hold, and now we're clicking through that backlog. The next sprint's going to be pretty light because we're doing we have an internal tech summit, and we're also doing some assisting the Evernym QA team with various Evernym products. But we are going to go through a number of old bug reports and decide whether they apply to the current code base or not on Indy Node, and whether we can close them or not. And we're going to fix a number of bugs in addition to that and measure those performance improvements that come from all the bug fixes we've done. So we're excited about that on the Indy Node side. On the Indy SDK side, we've teed up a sprint to continue some of the VCX work. We're going to build a dummy cloud agent to work with the LibVCX to show how it works. We are going to also continue to help the Evernym QA. And there's a Rust wrapper that we're adding. It's consumed by the SOV token. So we're going to get that into the SDK. And the next question is, we need to figure out as a team how many of the bug fixes we can do in the sprint as well. So that's what we're looking for there. Anything else we should share today? So thank you for the demo, everybody. It's nice to see the progress, and I'll upload this to YouTube fairly quickly, and in 2 weeks we'll do this again. Thank you.
Thank you.
Thanks.
Thank you. Bye.